So this is the another simulator, circuit simulator called Multisim, on which we'll do the simulation for the transistor circuit, which we have done it on another interface called Falsted. So coming to this interface, just see the outline where it will be containing all components on the simulator itself. We call that one as a component toolbox, and all instruments over there itself called as instrument toolbox. And after you take the component and take the instrument, combine together and form a circuit, can be saved. And each and every circuit will be visible over here. After you save the circuit, you can go with the simulation. There you can take a help of this module called simulation toolbox, where you can go and throw that run option, pause, stop, and we have to highlight the main option over here called interactive mode. Unless that it is in the interactive mode, we cannot use the instruments. Even the instruments are connected out there in the circuit. Let us suppose ammeter is taken across the branch, base branch or collector branch. If we cannot see the current flowing through the branch, through the instrument ammeter. So one thing we have to remember, when you do the simulation, it should be interactive when you wanted to use the when you wanted to use the instruments. Few people, what they do is they will be changing the mode. Instead of interactive, they will be going with a DC mode or transient mode, and they wanted to see the current through the ammeter. It will not be possible. So after knowing all these things, there is a workspace also, bringing all the components on the workspace and doing the simulation, right? So let us do the same thing for the transistor circuit on this multisim. We should know like a 5 steps process for every circuit. Let us do one by one. So first of all, I need a transistor circuit, means I need a transistor. I have to give one click on the transistor component, so that there will be a box opened. We call it as a select component box. You can select any one of the component. This is what the category of transistors available. I will not go all the things. I just go with the transistor virtual, and I will be selecting like transistor NPN. Give OK. So now the cursor will not come alone. Transistor will be there with the cursor. Wherever I move the cursor, the transistor also will go along with the cursor. So I can give one click so that the transistor will fit on my workspace. So this is what my transistor circuit. This is what my transistor. I'm trying to keep it on the workspace, and I wanted to extend the circuit. While extending my circuit, I have a problem. Maybe I have a problem. The workspace which I have it may not be big. So I have to know something about workspace, where I can go with the properties, where I can change the color of the workspace. Like if I wanted to go with a white color background, it can be changed. So here we have that options, and also we can change the size of the workspace also. If let us suppose in few cases, if the size of the workspace is like width around 8 inches, height around 6 inches, if I have that one, right, the workspace will be this much size. If I go with the multi-stage amplifier, if it is a complex circuit, multiple circuits need to be connected together and wanted to do the simulation, that is not possible with this much size. So there in that case, I can go with properties once again, and I can go with the extension of the width size and height size also. So after I give OK, I can see the workspace where it was become wider than previous one. So now I can extend my circuit, because that workspace is enough for me to connect my components. After transistor is connected on the workspace, we'll be continue with the connections, and by taking other components also, where I need voltage sources will be there on component toolbox. I will be selecting VCC, and that I will pick it and keep it on the workspace. I need a DC power source also. I will take it and keep it on the workspace, and need ground also. As we observe one thing, the ground also will be in the same category, voltage source category. It means like ground is also one kind of voltage source with a strength of 0. I'll keep my ground at emitter, and I'll give another OK, so that I can take another ground, I can keep it here. Otherwise, I can have an option that I can copy this one by using Control C and I can paste it where I need. Multiple components when it is required. Every time it's not required that every time you go there and pick the components and connecting is not required. You can copy there and you can paste it so that multiple components you can create there itself. So after you keep voltage sources, the current need to be flowing through the base and the collector. For that I need resistor. I have a resistor in the component toolbox over here and I have selected like resistor here. Maybe resistance value of 2 kilo you need not to select 2 kilo. Whatever the value selected I can pick it randomly and I can keep it there. Afterwards whenever it is required I can give double click and then I can change it. So here I can change the value if I want some other value I can change it here. And I wanted to shift it downwards in the sense like selecting the components, use up and down arrows so that the component will be moved on the sheet wherever it is required. And another resistor is required. I do copy and I'll do paste it here, but the component will not be required to connect in this direction. I wanted to rotate it. I wanted to change the orientation to be vertical. So I have used like Control R so that I could change the component direction. I have rotated the component. So after like all components are connected together, right? So wiring I have to connect them. So there is a there is a process called wiring with the flexibility provided by the multisim. So if you see the flexibility, when you keep my cursor towards the particular end of the element, so automatically the particular mode of the cursor will be changed into the wiring mode. So we can observe that the cursor as of now it is normal mode. It will be changed to the wiring mode automatically. No notation, nothing to be selected. So once the cursor mode is changed, there we give one click and we have to move the cursor up to the place where the wire need to be initiated and need to be terminated. There I will be giving one another click so the wiring between the two components will be provided automatically. So this is how I do wiring again. Give one click over here at the end, another click at the another end. So here also I do that same thing. I have option like a zoom in zoom out also by using a scroll bar in a mouse. So I can use up and down arrows also so that the sheet of that particular circuit workspace will move up and down also. So here I will use again one end. I will use one touch. I will go with another touch so that the wiring will be provided between these two. So where I need to keep my ground downwards in the sense I just click on my ground so that it will be selected. Then I use down arrow. The component also will move. One better feature over here in this tool is when you are trying to move the component, the wire also will be extended. So after you move the component, again the wiring is need not to be required. So this is how the connections are done between all components. After the connections are done, if any instruments required to measure any current across any branch, there you can go with go to I can go to instrument toolbox, and from where I can from where I will pick my instrument. After you connect a circuit, if you need any instruments to measure any parameter, I can go to the instrument toolbox. I can pick any one of the instrument. I can keep it here. Means in the second step, I will be adding my instruments to my circuit. So here instead of these instruments, there is a notations also we have for the ammeter and voltmeters. That notations I will take it and I'll keep one notation of ammeter here, and the display wherever I want I can move it. There is no issue with that. Another ammeter I will pick it and keep it here. If I give one click, that particular component or instrument will fit on my workspace. Yes, so all components are connected, formed a circuit. That is one first step, and took instruments also connected to my circuit. That is the second step done. Coming to the third step, whatever the name it is displayed over here, design one, with default it will come. What I do is I will be going with the save option, Control S, so that it will ask you on what name that design need to be saved. I want like test one. that is the name I wanted to prefer. Yes, I will be giving the name and give save. So automatically we can see this is the design toolbox. As I said, all designs which we have, it will be updated here. So with what name you preferred, with the same name itself it will be updated. So we gave test1 is the name, so on the test1 name itself it is updated. So first step, components are connected together and formed a circuit. In the second step, instruments are taken, kept wherever we wanted to measure any parameter. That is the second step done. Third step, we have saved a circuit. Saving the circuit is the third step. In the fourth step, we have to go with the simulation. For that, I have to go with this option run. Before you run the simulation, there is a mode of operation. You have to click on this one. Whether it is in interactive mode or in any other mode, we have to verify. In another modes, the results will be displayed somewhere else. We cannot see the results and cannot see the values across the instruments. So in the first session, we will go with interactive simulation. So I keep on interactive itself and I do the save, so that the mode of the simulation is saved on interactive. So now the components will be enabled. Let me show if it is not in the interactive. If I save my mode of operation analysis in another mode, if I save it, the instruments will be visible, but the display of the display of the particular instruments are not visible. So I will be changing again. I will come back to the interactive mode. I'll save it on interactive. I will save it on interactive. Yes, now I'll go with the save. So here I can observe there will be 11 milliamperes current is flowing through the base, and there will be this biasing circuit is pumping around 4.9 milliamperes. So we have to know the BJT how much he is expecting after. We have to know how much BJT is expecting. To know and to calculate the collector current expected by the transistor, right, with the equation beta times of IB is the collector current. First of all, we should know the beta value. So the beta value of the transistor parameter will be observed. If you give one click, there you can see edit model. Give another click on edit model. There you can see the BF. There's a maximum forward beta value of the particular transistor is beta. It's around like 100. After you observe the value of the beta, after you observe the value of the beta, like I can copy the particular text from somewhere and I can paste it. So that option I have it. I can modify it afterwards. The beta value of the transistor is given with around 100. So for my reference, I keep my beta value over here, and I will be calculating the collector current right now. So there is a collector current will be expected around beta times of IB. So beta times of IB, beta times of IB. So here I can calculate the beta times of IB is around 100 times of 11.1 milliamperes. So it is around 1110 milliamperes. So there around you can say there around 11,000 1100 rupees he is expecting for doing this task. He is expecting 1100 rupees, right? But he is giving only 5 rupees. So now we should know what to be done to the circuit, what kind of modifications done to the circuit, so that transistor is going to be bringing into the active region. So now I will stop the simulation. I can save the circuit. So I can move the sheet. So this is the empty sheet where I wanted to save my another circuit. In this circuit I will do the modifications. So now what modification I am trying to do is, where at a base terminal, whatever the voltage source that I have, I wanted to reduce the strength by giving double click, and I can change the value. So automatically the value will be changed. So previously around like 12 volts the voltage strength was very high, so that very high current was pumping. There around like 11.1 milliamperes current was pumping. Now if you do the simulation once again, it is coming to 183 micro. So that is how I reduce the current over here. Let me do the simulation once again and let me check 183 micro, 183 micro into 100, it will come around 18.3 milliamperes. So now when you reduce the work, when you reduce the strength of the base for given work, he will be expecting around 18 rupees now. So he was able to give only 5 rupees. Previous case how biasing circuit gave 5 rupees. So I didn't change any biasing circuit at the collector, so that still it is able to give 5 rupees itself. But for given work he is expecting around 18.3. So what I have to do? I have to reduce the work further. I have to reduce the strength of the base further so that the base current need to be reduced. What I do is the resistance value I will be increasing now. Instead of 1k, I will be increasing to the 10k. So here I can see the warning message. The simulation is running. Any change you made in the design will not take effect until you restart the simulation. What it says is, even you change the resistance value 1 kilo to 10 kilo, the value will be reflected, but the simulation results will not be reflected. The simulation value will not be reflected. So simulation value, the ammeter was showing around 183 previously. Now again it is showing the same value. So this value will be reflected after you restart it. Means I have to stop it and I have to go with the run once again. So that value will be reflected. The new value will be reflected now. So now once I increase the strength of the resistance so that it is able to limit the current, it is now came with the 20 micro. So now let me calculate how much salary he is expecting for the given work is. It is around 20.7 is the input. So for that he will be expecting 2.07. This much salary he is expecting. So around 2 rupees. So previously he was giving able to give around 5 rupees. Now if he is asking around 2 rupees, he is able to give for sure. So the transistor is provided with a sufficient current. What transistor is expecting around 2 is provided by the biasing circuit, so that I can say the transistor is properly brought into active region. So this is the one method where I can bring the transistor to the active region. So now I'll go with another method. Instead of adjusting a biasing circuit at a base, I can go with another option. The same circuit, let me copy and I can save it. There is no process, we can copy and paste, we can do it when the simulation process is running. I have to stop, then again I have to copy, again I have to copy, and again I will try to save it. So this is how I got a third circuit. From the third circuit what I do is, from the third circuit what I do is, from the third circuit what I do is, so I will not keep that 10k here again. So I will be keeping around 4k, let us suppose 4k or 5k, let us suppose. So now if I do the simulation, so it is asking around like giving around 38 micro. So if I calculate the salary which he is expecting, the collector current he is expecting around 38.2 micro, so it will be around 3.8. So it is not above 5 volt, it is not above 5 rupees, so it can give it. So if I reduce that further, for suppose it is around 2k, it is around 2k, it is around 2k. So for 2k resistance the current value is around 92 micro. Let me calculate the collector current which is expected by the transistor is around 92.2 micro. So it will be around 9.22. So 9.22 milliamperes. So now the transistor is expecting 9 rupees around. So he is able to give 4 rupees. So what I do is, I don't want to do any adjustments at the base. I wanted to do only adjustments at the collector. So what I do is, I will be increasing the strength of supply so that it is able to pump more current which is expected by the transistor. It's around 9 rupees is expected. So maybe because of the high strength, maybe he will pump around 9. So for that sake, let me check with the 12 is the strength of the voltage source. I do now. So 9 rupees is expecting in the sense, no, for the given change it's around 85 microamperes. Let me calculate once again. 85.2, it will be around 8.55. So he will expect around 8.55 rupees, around 8.52 rupees, around 8.52 rupees around. So that much was provided by the resistor. Still, if it is not provided, in the sense, I can change the biasing network. I can change my resistance also. Biasing network is a combination of voltage source along with the resistor. Um, so now around 8.52 milliamperes expected by the transistor was provided by the biasing network properly. So after you design a biasing network properly by doing some sort of adjustments, finally we brought the transistor into the active region. So this is the procedure how this circuit is not in the proper region of operation, which is not in active. So we cannot use this circuit for amplification. Whatever you do modifications, you give the input will not be amplifying at the output. So first thing we do is, before you give the input signal to the circuit where amplification needed, you have to design a biasing circuit such that bringing the transistor into the active region is the process need to be done. So in the process you can take any method, you can go with any method, either adjusting base biasing circuit or collector biasing circuit. So the two ways how you do the biasing and making the transistor to operate in the active region